All right, so since we're comparing function notation, I thought we might as well go ahead and interpret and compare some interpretation of function notation. So I'm going to do these two problems and then you're going to jump right into your practice problems. Stella is going to drive from her house to city A without stopping. An equation determines Stella's distance from city A t hours after leaving her house is D equals negative 60t plus 240. Number one, what is the y-intercept? So of course you can always type it in, but some of these questions are very quick for you to see what different answers are. So I'm going to talk about both, but I've already gone ahead and typed it in for you. If I wanted to look at the y-intercept, I just go right here, click in here so that it can give you that dot, and there is a y-intercept. However, this would have been faster from just seeing it from the equation. So what is the y-intercept? Well, for that, you need to remember this looks like a linear equation. What is a linear equation? So if I go back to my formula sheet, here's my linear equation. We've looked at this extensively. So y equals mx plus b. And you can see that you can match it here. Y equals mx plus b. And you know that your b is your y-intercept. So what is my y-intercept? I can see that right out of the problem. It's 240, or I can put it in and look at the graph. So my y-intercept is 240. And what does that mean in the context of this problem? So think about what's happening. Stella is driving to city A. So she's starting at her house. She's driving to city A. If her y-intercept is 240, right? She is 240. I don't know if this is miles or I don't know the distance. She's 240 distance away from city A from her house. So what does this mean? The distance from city A at the start, because you do need to, or at x equals 0, at t equals 0, because they're actually using t. All right, so the distance from city A at t equals 0, or initially, that kind of word. All right, what is the x-intercept? So again, two ways what we can do it. I'm going to definitely show you both. So I just clicked home. Here is the x-intercept is 4. So the x-intercept is 4, and now I'm going to show you mathematically what that means. We know that at the y-intercept, x is equal to 0, and at the x-intercept, y is equal to 0. So if y is equal to 0, I'm going to show you how to do this by hand real quick. That means this is equal to 0, and so we have 0 equals negative 60t plus 240. And we're going to solve this equation. We're going to add 62 to both sides. So this is going to be 60t is equal to 240. Divide both sides by 60, and you're going to get t is equal to 4. So you get the same number, whether you want to look at it at the graph or whether you want to calculate it. It's not a problem. Whatever your preferences is fine. So 4 is the x-intercept. What does this mean? Well, she started at 0, right? Because I know that because her y-intercept was 240 at 0. Before she moved, she was 240 miles away. Then she starts moving, right? She starts moving until she gets here. What's happening at that point? Well, this is 4. I don't know if this is hours, if it's, or it says t hours. All right, so 4 hours, and I'm going to actually write the hours in here. 4 hours, okay? 4 hours later, she is 0 miles or 0 kilometers or whatever the units they're using for distance. She is 0 away from city A. So 4 hours later, she arrives at city A. That's what it means. So 4 hours later, she arrives to city A. You know, something along those words, okay? So the x-intercept is basically when she is 0 distance away from city A. What is the slope of this equation? So we know that the slope is negative 60, and that makes sense because you can see this graph is going down as opposed to going up, right? And what that means is this is the speed in which she is driving. So and again, is this hours? It is. She's driving 60, I don't know, miles, kilometers, whatever the units are. She's driving 60 miles every hour. Because remember, slope is change in y over change in x. So this is a rate. So in other words, you can think of it like this, because negative 60 divided by 1 does not change anything, right? So she's driving every 60 miles or kilometers every hour, okay? So it's her speed. So what is the slope? An equation. So her slope is negative 60. And what does that mean? It depends what options, if it's multiple choice it gives you. This could be the speed she travels, the rate of change, per hour, or we could just say she goes 60. And again, I don't know what the units are. Let me say miles. She goes 60 miles every hour, just something along those lines. So there are different ways in which you could say that is, but it's basically how she's getting closer and closer and closer to city A. All right, so that's linear. Now we're going to take a look at a quadratic one. So a rocket is launched in an air. And again, you could do this by hand or by calculator. I do not mind whatever your preference is. I'm going to go ahead and show you by calculator because unfortunately I won't have time to do both. All right, because it's more so the interpretation is what I need. All right, so here's the equation. All I did is type it into Desmos. So a rocket is launched in the air. Its height is in feet, given by this equation where t represents the time after launch. What is the rocket initial height? So we know that's my y-intercept. So again, you just click in here. It'll give you a dot. There it is. So my initial height is 144, and this is feet because the question is talking about feet. All right, so how long is the rocket in the air? So this rocket, this is weird. I guess this rocket just crashed because it didn't even go up. It just went right down. So this rocket didn't even launch. It just died. But anyway, how long is it in the air? So it dies over here. It gets to 0 at 3 seconds, right? So it's 3 seconds in the air. Is it? This is in seconds. Yes. 3 seconds. It literally crashed is what this is saying. All right. So it started up there and then it just came down. Boom, boom, boom. At this point, it hit the ground. So it didn't go anywhere underneath. So 3 seconds later, it hit the ground. How many seconds have gone by when the rocket is at its highest point? All right. So where is the highest point? That's the vertex. And it just so happens the vertex is the y-intercept. So how many seconds have gone by? 0 seconds. No time has gone. My vertex, my maximum height is right there at 0 seconds. What is the appropriate domain for the situation? Okay, so let's talk about domain. Domain is X, left to right. All right, over here there's a graph, but can I have -3 seconds? No. So I must start at 0, right? What is the maximum number of seconds I can go? 3, because what happens after 3 seconds? Then I'm at negative height. So an appropriate domain within the context of this problem is between 0 and 3. Can I include those numbers? Absolutely, because at 0, it's at maximum height, and at 3, it hits the ground. So you do include those. Interpret the coordinates of the vertex in context. So what does 0, 144 mean? So 0, 144 in the context of this problem means the rocket is 144 feet high. After 0 seconds. Okay, and that's pretty much it. Let's practice.